Number 8, we're trying to prove that this statement is true. To do any proof, you want to start out with a true statement, such as sine of b over b equals sine of a over a. And you want to try to manipulate it using algebra and facts to make it look like what you see up there. Well, this problem is actually very similar to the one that we did earlier. Let's get all of our a's and b's, the little a's and b's together. Let's get all of our sines of angles together. To accomplish that, I'm going to multiply both sides by AB. No, I'm not. I'm going to multiply both sides by A. Please understand, there's not one way to do these problems. Sometimes when I'm faced with so many options, I don't know what to do. Just multiply both sides by A. That's the multiplication property of equality. It says you're allowed to multiply both sides of an equation by the same number. Now I'm going to divide both sides by sine of B. If I do that, I'm going to get A divided by B equals sine of A over sine of B. That's the division property of equality for real numbers. So you can divide both sides of an equation by the same thing and it doesn't change its value. Now let's add 1 to both sides of the equation. And why are we adding 1? Well, I notice what we're trying to prove, we're adding something. So I'm going to add 1, and it doesn't make a lot of sense at first, but as we work through the problem you'll see that it works out well. And the reason I know you're supposed to add 1, unfortunately, this is a terrible answer. I've done this problem so many times that I know that it works out this way. On the left, to add a fraction, a over b, and 1, you can't. You need common denominators. So the denominator would be b. On the right, to add 1 in this fraction, you can't. You need common denominators. So I'm going to change 1 to sine of b over sine of b. Then when I add these, I get a plus b over b equals sine of a plus sine of b over sine of b. If you compare that to what we're trying to prove, we are so close. And yet we're not. Unfortunately, we got a little bit of work to do. What's on the top should be on the bottom. What's on the bottom should be on the top. I am going to multiply both sides by my denominators. If I do that, on the left, I'm going to get a plus b times sine of b. On the right, I'm going to get b times sine of a plus sine of b. Multiply both sides by our denominators, b sine of b. Look at what we're trying to accomplish. We want a plus b on the bottom, and we want sine of a plus sine of b on the bottom. So I'm going to divide. Usually I don't show these little things here, but I'm going to show it here just to make sure that you're seeing what's happening. I'm going to divide both sides by a plus b, and also by sine of a plus sine of b. Parentheses here are needed if you show what's in green. On the left, your a plus b cancels, leaving you with sine of b divided by sine of a plus sine of b. On the right, your sine of a plus sine of b's cancel, leaving you with b over a plus b. Really close now. We are cooking with gas, as they say. Then, what we can do next is My brain has frozen on me to give you the reason. I forget what the reason is. It's a symmetric property. That's what it is. This is the symmetric property. The symmetric property says if you have an equation, like we have here, you can take what's on the left side of the equation and put it on the right. Take what's on the right and put it on the left. That's the symmetric property of equality. Just a quick example of that. We're finished with this problem. Quick example would be to say 7 equals 1 plus 6. Therefore, 1 plus 6 equals 7. That is the symmetric property of equality. Woogie, woogie, woogie. That's not part of the problem, so let me get rid of it. We end up with what we were supposed to, so we have accomplished our goal.